What happens when you use Entity Framework Core and you have an entity with an obvious natural key, something that naturally identifies that entity? Do you still use auto-increment IDs or GUIDs in the database because EF Core is somehow forcing you to do that? Well, you might be surprised to learn that EF Core 10 has a native support for natural keys for entities. You can declare a natural key for an entity, you can insert an entity with that, you can use that as a constraint and even as a foreign key for other entities. Everything works natively in EF Core. That's what I will show you today in this video, so please join me in the demo. This is one fairly simple entity, the invoice. It has a bunch of properties, validation and everything. There is a database setup in the DB context for that. But it also comes with the auto-increment ID. Let's see what using this entity looks like. I have prepared an invoice number, the date it was issued and the currency. So let me create an instance. Let me add lines to the invoice. It's very easy. I can add it to the DB set and save changes. Everything will work like a charm. This object will have its auto-increment ID assigned. But what happens later in a later request when the user asks to see that same invoice? Well, that would require the unique identifier. I would need to poke that ID out after saving the entity and somehow communicate that to the user so that the user can later send that same ID and say, this is the entity I want to see. The rest is straightforward. Get to the invoices DB set, include the invoice lines, and find the single entity with this ID. I will print it out, I will run the application, and you will see it. That's it. This just works. But I don't like it. Let me show you what a database looks like. There is the table for invoices and there is the table for invoice lines. When I query them, the data will just be there and they will all have the auto-increment ID. However, this is what we are really looking for. The invoice joined with the invoice lines, now joined by the invoice ID, the foreign key, the auto-increment ID. When I query that, we will see the invoice data plus all the lines in that invoice. So this is, let's say, the default configuration. This just works in EF Core. But I have objections on this auto-increment ID. It could be the GUID too. I don't like auto-increment IDs, especially if I'm showing them on the network. Well, I consider that even a security issue because you're telling the world at least how many inserts you have in your database. Well, you're emitting the information you might not want everybody to know. The GUID would remove that concern, but it won't solve the substantial issue that I am publishing an ID which means absolutely nothing to anyone. This is the technical concern of the database engine. Nobody cares to know this value or a GUID that would stand in its place. This is what I actually want. I want to communicate the invoice number, the issuing year and the sequence number of the invoice, because that, not only that is unique, that is legally unique. There can be no two invoices issued by the same company with the same invoice number. It is a proper natural key. Now, both these properties are private, so I have to use ef.property to fetch them. I will fix that in a moment. What I have already fixed is that I don't have to communicate the auto increment ID to anyone. I only communicate the invoice number. And this is the solution for readability. I have convenient extension methods in the infrastructure layer where I can hide the details of the database model. So let's fix this query. With lines, we'll include the invoice lines, and where number, give it the number, then just take the single async. This begins to look like a proper query specification. This is what I want to have. I want to talk in clear business terms, not in terms of technical implementation of the database. AKA the natural key. The invoice number is the natural key for the invoice. And from this point on starts the refactoring, where I will remove every mention of the ID from the model. The invoice will have no ID anymore. The ID will exist in the database, but only for the sake of identifying the row in the database. Why would I care about that? Let the database care about that. That's the database's concern. And so we get to the DB context, where we need to configure all this. First, there's no has key. I will say that the ID property is a value generated on add, and it is called ID. It's still the key, but there is no property in the model. This is how you specify shadow properties. So there will be a column in the database associated with each instance of this entity, but the in-memory entity will not see its value. You can access that value if required using EF Core, but you will not require that. That's the story. And then comes the invoice number. You see, I had the unique index already because the invoice year and the sequence number inside that year, those two must be unique. That's the legal requirement. I must not allow myself the freedom of making such a bug as creating two invoices with the same number. But now I want something else. I will delete the unique index and I will introduce what EF Core calls alternate key. I will just say the entity has an alternate key consisting of these two properties, which are private, so I have to give their string names. I cannot use lambdas. We are at the brink of the completely new database design now. I will now show you the migration produced by this change, and then we will use this as a foreign key in invoice lines. But before that, let me remind you that this channel and everything on this channel is free, but only thanks to the patrons who are sponsoring the content I'm creating. If you like what you have learned from this video and all other videos on my channel, then please consider joining the growing community of patrons on my Patreon page. Thank you very much. Now, let me show you the migration. Here it is. Add unique constraint with these two columns in it. But let me show you the down migration. It shows what used to be here. The index, there was the unique index with those same two columns. You saw me create that unique index. Now I'm creating what? A constraint. What is the unique constraint? It is stronger than unique index. It is the same as the unique index in respect that it is unique. You cannot insert two pairs of invoice year and sequence at the same time. That would be a collision and the operation would fail. But the constraint has one additional property. These two columns are now immutable. You cannot change an alternate key once you have inserted it into the database. But there is more. This is the invoice line model. It also has the auto-increment ID. I'm deleting that. Nothing will have auto-increment ID visible in the model itself, though the ID will remain in the database again. Now first let me add that shadow property for the ID. Now I want to restructure it so that it doesn't use the invoice ID foreign key anymore. I wanted to use the invoice number, which consists of two integers, the year and the sequence. And I want to say that these two columns in the invoice line are referencing the invoice year and invoice sequence in the principal table, the invoice. I will also say that it's required that this was missing previously, now it's fixed. Let me show you the migration for invoice lines this time. There will be the two new columns in invoice line. One specifying the invoice year, the other specifying the invoice sequence number. And there will be the foreign key with these two columns, you see? Not an invoice ID pointing to the ID in the invoices table. No, but the real natural key is now the foreign key in the invoice lines table. So when I query the invoices and invoice lines, the invoice will remain the same, but these two columns, number year and number sequence, will now have a different meaning. And here they are in the invoice lines table. This is how the two values are used as the foreign key in the invoice lines. And when it comes to querying the join between the invoices and invoice lines, we will now do that over these two columns, not the invoice ID anymore. And when I query it this way, everything will work as before. Even the performance will be comparable because there is the foreign key constraint in the table. What are the consequences in the consuming code? What do you think? Well, believe it or not, there are no consequences. Everything will just work. Let me quickly run the application. You see, it just works. The query would be a bit different. You saw what it will generate. It will join the two tables using the new foreign key. But everything will simply work. This is the way how you can remove an auto-increment or any other surrogate key generated by and owned by the database from your entities when an entity has a natural key. It's very simple in the end, and EF Core supports that out of the box.